Hi there, I'm Mark Dumas. Welcome to another episode of Laboratory of Irreproducible Results. This is episode 7, and I'm going to cover in a little more detail a project that I covered in the previous episode having to do with the rehabilitation of a 3D printer called a PrintrBot Simple Metal. In the previous episode, I covered what we did for rehabilitating this printer. In a nutshell, it has to do with replacing the control unit underneath here with a ramps controller board, complete with a new operator interface and a custom display case. I also added a heater to the build plate, and I replaced the original printhead components with a new hot end. I did a few other things, but that's kind of the main stuff that allowed this thing to get back in operation again. Now, when I posted that first high-level overview of the rebuild of this printer, I got some questions concerning how to go about attaching some of the sensors in the PrintrBot to the new ramps board, and some specific questions about how to go about configuring the Marlin software. So I thought what I'd do in this episode is cover those two areas in a little bit more detail. So the first thing we're going to do is flip the printer over and go through a wire-by-wire description of where each of the motors and sensors connects into the ramps board. And then in the second half of the episode, I'll go through some of the high-level sections of the Marlin Code and show how I configured that specifically for this printer. Okay, so I've got the ramps board pulled out from underneath the PrintrBot. Before we start going through wire by wire there, I just wanted to point out that many of the sensors and motor, the sensors that come with the PrintrBot may have plug connections that are different than what are required by the ramps board. So if you don't already have one, you might want to get one of these kits that has these pins that you pick off one at a time and you crimp onto your wire using a tool like that. And then once you have your wires in a pin, if you've got, say, a 2-pin connector, then you'd get the right shroud. Here's one for a 2 connector, and that slides over those pins. They clip in nice and firm, and that's what gives you the ability to plug those sensors into the ramps board. So let's take this just sort of wire by wire. Let's start over here in the lower left-hand corner where the green power entry block is. I've got power, DC power is coming in 12 volts in these two heavyish red wires. Positive on the top, negative on the next one down, with the these wires down here are to jumper power over to the other section of the board. Now, you may recognize that these wires are a little bit heavier than the stock PrintrBot wires, and that's because in the process of adding a heated build plate on this machine, the current requirements went up dramatically, so I had to rewire all the incoming DC wiring to be a little bit heavier duty. Alright, so since we've touched on the topic of heated build plate, let's go there next. There's 4 wires coming out of the heated heat pad for the build plate. The 2 heavier wires are right here. This is for the resistive heater. Those go into the bottom 2 screw connections on this blue strip. On my particular ramps board, that actually says printed on the PCB that it's the heat bed. Okay? And then the thermistor that the firmware uses to figure out how much energy to send down those heavy red wires, the thermistor sensor is coming back on these 2 thinner red wires. And if you follow those over here, they're plugged into this area of the board. You can kind of make out a strip on my board. This is 6 pins on a yellow base there. There's 2 over here that aren't used. The 2 in the middle is where the thermistor for the heated build plate comes into. And again, since a thermistor is a resistive element, there's no polarity concerns here. You can just plug this in any way you want. Okay, now let's move to the components coming off of the printhead. So the printhead has got, the heater block for the hot end. It's got a fan for the top end to keep the top end of the heater of the hot end cool. It's got a thermistor so that the firmware can keep track of the temperature of the hot end, and then there's 2 fans. So let's just take those one by one. First of all, the kind of the heavy-duty current requirements on that hot end are for the heater block, and those come in on these two relatively heavy red wires over here, and they're coming into the top two pins, top two screw terminals, if you will, of that set of 6 screw terminals on the left-hand side of the board. Again, that's a resistive heater element, so you don't have to worry about polarity here. These wires can go in either way. Now the thermistor, for keeping tabs, so the firmware can keep tabs of how well it's doing on maintaining the temperature, are coming back on these two lighter white wires, and they're plugged in over here, back on that 6-pin strip on the far left 2 pins. All right, now the fan on the hot end, I'm using an E3D V6 hot end. It's got a fan that blows over those fins to keep the top part of the hot end cool. That we want to just stay on all the time. Anytime the printer is powered up, it just needs to see 12 volts. So that's these 2 wires coming in here, and I found a spot on the ramps board next to this fuse here, between that fuse and this driver module for a stepper motor that that just provides 12 volts, uncontrolled. Just, you know, it comes on whenever the thing is powered up. Now, polarity is key here. I've got red on the top, black on the bottom. If you find out that yours is blowing air the wrong way, you can come in here and just flip this around the other way. There's no penalty for getting that polarity wrong, other than having to come back and change it later. Now the other fan that's up on the print head is the one that's cooling the molten filament as it's coming out of the nozzle. Now that one we do want to be controlled under firmware. You know, typically you want that first layer of printing to be with no cooling, part cooling fan on, so it sticks to the build plate better. And so we want that fan to be controlled by one of these transistors, and that's coming in here to the middle two connections of this blue barrier strip. And let's see, mine is labeled heater 2. That's if you had a second extruder, you know, you had a dual head printer. In this case, we're going to reuse, actually just use that channel or that connection for controlling the fan. And I'll get into a little bit later how we tell the firmware what's actually hooked up here. Again, polarity is key here. I've got the red wire screwed into the bottom one. I see it just came loose, so I'm going to have to reattach that one, and then the black wire comes, or the ground wire comes into the third screw down. Okay, so I think that covers everything on the print head. A lot of the wires you see here are these 4-wire connectors, and these are for each of the stepper motors. So this group of 4 wires is for driving the X-axis stepper motor. This one is for controlling the Y-axis stepper motor. This one, which I'll now plug back in, is for the Z-axis. And then there's one more up here, a little bit buried under these wires. This one is for the motor that pulls filament through the extruder. Now you've noticed that I've got all the connectors aimed the same way. I've got the red wires over to your left towards the power block. And as you're probably aware, you can reverse the direction of a motor by simply unplugging a connector, turning it 180 degrees and plugging it back in. But for the purposes of this episode, I'm going to keep these all red to the left, and then we can also control which direction the motors turn in the firmware, which I'll cover later. All right. Now, one other area that I think took the most time to figure out and is probably the most confusing has to do with the limit switch connections. And the limit switch connections are all up here in this block of pins in the upper left hand corner. First of all, this set of 4 pins right here, this is for an I2C connection. We don't need to bother with that on this particular implementation. What we really want to focus in on are these 3 rows of pins. Now on my board, they're kind of color coded. There's a row of 6 pins that have a red base. It's a little hard to see in this angle, but the middle row of 6 pins has a blue base, and then there's a top row that has a yellow base. And the best way to think about these pins is as columns of 3 pins. So over here on the far left column of 3, this is where you plug in the minimum limit switch for the x-axis. Now, what you see is that we've got a yellow and a black wire going into the upper and middle rows respectively. So what's going on here is that red connector, that red row at the bottom is a +5 connection, 5-volt connection. The middle blue row there is a ground connection, and then the upper row, the yellow, is this signal coming back from the sensor to the firmware that tells the state of that limit switch. So what we need, fortunately, we don't have to fill up all of these pins. On the PrintrBot, we have switches in the minimum limit positions for each of the axes. So we're going to put the x-axis limit switch pins on those upper left 2 pins. Again, since this is a kind of just a dumb mechanical switch, it doesn't matter on polarity if you end up getting the yellow and the black reversed here. It's okay as long as they go into the yellow signal and the blue ground positions on that far left column. Okay, now the next column over of 3 pins you'll see are not being used here. That's because this is the maximum limit switch inputs, and on this printer we don't need to worry about that. Next over is the Y minimum limit switch, and again it's got a yellow and a black wire coming in from the switch that clicks when you hear the y-axis go to the minimum position. And then next to that is again a couple of unused pins because we don't have a maximum limit switch on this printer. And then finally over here, something a little different. We've got, you see these 3 wires coming in. This is the minimum limit switch. Actually, it's not a switch, it's the proximity detector for the z-axis. Now this, on the PrintrBot, that type of sensor is an active component. So there's a little LED, the active element that's actually sensing when it's close to the metal of the build plate requires some voltage. So this is the one sensor in this area that actually does have a red wire going down to the red row, in this particular case, right there, in addition to a ground wire right there in the middle, and then the yellow wire going back to the proximity sensor. Now I think, if I'm not mistaken, I've spliced these wires up near the proximity sensor head, and the color may change. The wire coming out of the actual sensor I think may be brown or something, but you need to kind of figure out which one is the sense wire that's telling the firmware, hey, I'm close to the print head, and that's the one that needs to go into this upper yellow block position. And then once again, since we don't have a maximum limit switch on this printer, the last row of 3 pins here is unused. All right. So yeah, that's kind of a can be a little bit of a confusing area to deal with, but hopefully that makes it clear. And if not, just shoot me a question in the comments. All right. So that covers, let's see, the print head, the motors. I think that's about it. The only other thing we see connecting in here are these ribbon cables that go from the display adapter daughter board here to the actual user interface. You can ignore these little red wires. Those are my repair job. As I mentioned in the previous episode, in order to get this to all fit underneath the case of the PrintrBot, I had to put in 90-degree connectors here instead of the ones that shoot straight up. And in the process of doing that, I damaged some lands, and this is my repair work, and that's all I have to say about that. All right, let's go through the Marlin Code and see how I've got it configured for the PrintrBot Simple Metal. First of all, I'm assuming you know your way around the Arduino IDE, the Integrated Development Environment, and know how to bring up the Marlin Code. I'm using level 1.1.9, and I get asked a lot, why did I use that level and not 2.0? 2.0 is where new function, including support for 32-bit processors, is going. And as of this particular episode, I'm still seeing folks online say it's not as stable as folks would like it to be. So I'm using 1.1.9, which is 16-bit support, which is exactly what Arduino and RAMPS is using, and it's quite stable. So that's why I'm using that level. So let's just go through this section by section. I'm going to scroll down to about line 136 to this area here called Define Motherboard. Okay, so first of all, as we go through here, keep in mind that the double slash here means a comment. So here's a comment for our purposes. That's not something that the IDE is going to compile. So there's a lot of places where we just need to uncomment and comment out the correct pound define statements. So in this case, this pound define statement says what motherboard is Marlin expecting to see out there. So there's a long list of ones that it supports. I've already looked this up in the other tab down the road here that says boards. And what you need to have in here is one that says board underscore ramps underscore 14 underscore EFB. So obviously we're dealing with a ramps 1.4 board. And the EFB here is key. This tells Marlin how to use the 3 MOSFETs that are attached, that we were attaching to via that blue connector in the previous part of this episode. So this says that the top 2 terminals that we connected our heater element to for the print head is for the extruder. The next 2 terminals down is for a fan, for the part cooling fan, and then the bottom 2 is where we hooked in our heated build plate B. So EFB for those 3 things. Obviously, if you had a printer that had 2 extruders, you would see 2 E's in here, and there's all different combinations, but the way we're using this for PrintrBot, that needs to be the EFB. Okay? Here's kind of a fun one. This define statement is uncommented and therefore active. You can set up a custom machine name that actually shows up on the LCD. I chose PrintrBot. Okay, now down to line 283, we're going to look at thermal settings right here. This long list of comments is just a definition by number of all the thermistor or thermal elements that Marlin supports. We are using this number 5 100K thermistor for controlling the E3D printhead, and the other one is this 75 down here. It's called a 100K generic silicon heat pad. Okay, so when you get down here to the actual executable code, this define statement, it looks like Marlin can support up to 5 different extruders. We have just the 1, so we're putting in the 5 here for that first thermistor I mentioned. And then down here for the sensor for the heated bed is where the 75 goes. There's zeros in these other positions because we don't have a enclosed chamber or multiple print heads. Okay, what else? I don't think I changed any of the other sections. I don't think I touched PID settings. What we're looking for now is end stops. Okay, right here. So some pretty key stuff here. So this defines to Marlin how the end stops are configured for all 3 axes. So you'll notice here we have all 6 of the combinations of minimum and maximum end stops for all 3 axes. We've defined this one that says use xmin underscore plug. we've commented out one that says use the Y min and the X max and the Z max plugs. So this was a little confusing to me. We're actually using, I'm not sure what plug means in this context. As you recall from the previous part of this episode, we're using the minimum pins marked minimum on the ramps board, but this is what I found to work. We're using the X min, Y max, and Z min, and I think this has to do with the fact that the Y axis on this printer has its end stop at the maximum position, but this is what I found to work. Okay, then down here a little further, this tells Marlin whether the action on that switch is is true when it's active or false when it's active. And so for the three that we're using, we have an X min end stop. We're telling it don't invert it. Okay, and for the Y max, we're saying also don't invert it. And for the Z min probe, we're saying don't invert it. These others I don't think matter. I'm a little confused as to why there's two trues in here, but I think it's for these end stops that we're not actually using for this particular instance. So if you just set them up like this, it should work for the PrintrBot. Okay, let's see. Next up is the movement settings, which is this section right here. This line I think came uncommented out, so it's an executing one. This says what we're doing here is called default axis steps per unit. This is where we tell Marlin how many steps do you have to step the stepper motor in order to get to 1 millimeter. And so for the X motor, we're telling it if you need to move a millimeter, you've got to hit it with 80 pulses. Same thing with the Y. The Z, to move it a millimeter, you've got to hit it with 2020 steps. And for the extruder, a millimeter's worth of filament takes 96 steps. Okay. I don't think I messed with these feed rates or acceleration. Next up is the Z probe options right here. This line, I don't recall if I had to uncomment it. You do need to uncomment it if it is in the default code, but this just says the Z minimum probe is using the Z minimum end stop pin. In other words, the probe is doubling as the end stop. And then, don't think I had to touch any of this stuff. Probe offsets is the next one. So there are operations where Marlin needs to know that the Z probe isn't in exactly the same spot where the extruder nozzle is. So you have to tell it here that the probe is offset from the X 25 millimeters to the right. It's also, the probe is 3 millimeters behind the nozzle, and it's 2 millimeters above the tip of the nozzle. Okay. I think I just left these all as defaulted. Next section was machine. Right in here. Okay, I think this is key as well. This says invert the stepper direction. Okay, so this is a place where you can change the direction of a motor if it's going the wrong way. So these are, this is saying, do you need to invert the X direction? I said false. Do you need to invert the Y direction? I said yes. Again, I think this is because the fact that how we have the sensor for the end stop on the Y is in kind of an odd place, and then we also said false for inverting the Z direction. I think everything else here down to, okay, this section on homing, right in here, this says what direction does Marlin want to send the stepper motors when it gets the home command. So it says this is telling it to to move the X motor in the back to the minimum position, what we have defined as the min position. That's why that -1 is there. But for Y, I've got a 1 in there, and that's telling it to head to the max position. Again, because the sensor switch, the limit switch for the Y axis is in the max position. So that's the direction it needs to go to find that switch. And then the Z home direction is -1 as well, because it's at the bottom. It's when the probe hits the build plate. And then this next section tells Marlin a little bit about the build volume. It says the X build bed size is 152 millimeters and Y is the same. I think this printer is advertised as 150 millimeters, but I discovered that I could squeeze a couple of more millimeters out of it. And then this section is travel limits after homing. So X, Y, and Z min, those coordinates, as you would expect, are 0 after a homing. Y max, when the head is sitting at this 0, 0, 0 position, the Y maximum position is equal to this X bed size, which is 152 millimeters away. And same for the Y max position, it just assumes it's going to be the Y bed size. And then the Z max position is 160 millimeters above it. Again, I think this printer is advertised to have a 150 millimeter Z height, but since I put in a slightly shorter E3D extruder head, I've tinkered around and figured out how to squeeze 160 millimeters of build height out of this. Okay, that's homing. Okay, now we talk about bed leveling. Marlin supports all these different types of bed leveling, including fairly evolved mesh bed leveling. I found that for a small printer like this, this 3-point bed leveling has been fine. I set it up this way at the very beginning, and I've never had any trouble with it at all. So if you go down here to the define statements, you see I've uncommented this first one that says auto bed leveling 3-point, and I've left commented out all these other options. Now, so what's going to happen is this will tell the printer before each printer operation to go do this leveling operation, and it's going to assume that the build plate is flat, but that it may be a little off kilter relative to the build axes. So how many points does it take to define a plane so that Marlin can do these corrections on the fly? Well, that's 3 points. So you have to scroll down here. The coordinates for setting up the 3 points for some reason buried in this mesh section, but it's right in here. If auto bed leveling 3-point is enabled, then define these 3 points. So you need an X and a Y coordinate for point 1, an X and a Y coordinate for point 2, and an X and a Y coordinate for point 3. And if you think about where these are on the build plate, 75, 145 is kind of in the middle of the build plate, but at the back. This next one, point 2, 150, Y5, that's kind of the lower right-hand corner or the forward right corner. And then this third point is kind of over near the origin or the lower left-hand corner of the build plate. So you'll see you can set this up any way you wanted. I just figured I wanted 3 points that were kind of towards the edges of the build plate. And again, I did it this way the first time, and it's performed flawlessly. The last section is in this section called additional features. One gotcha down here. Let's see. Nozzle cleaning. I think it had to do with the LCD. Yeah, LCD and SD support. I think the language was defined correctly. This line I don't think I changed. This one right here, SD support. As you can see in the comments, it says SD card support is disabled by default. So yeah, the first time I tried to print anything with this new control unit, it couldn't see the data on the SD card support. I don't know why they default this to off, but I had to come in here and take out the double slash in order to enable that. Okay, well, the rest of this I am pretty sure was all, I just left it as default. Hopefully this gets you going if you're trying to do the same sort of thing for a PrintrBot Simple Metal. Like I said earlier, this printer's been a real workhorse for us in the last 9 months since we got it running. I think there was a period around the Christmas holidays when a friend of mine was asking me to help print out a bunch of parts. I think I had this printer along with some of the other ones in the stable here running pretty much 24 hours a day for at least a week, and it never hiccuped. It's been a real solid printer. So I hope you get the same results if you're attempting the same sort of upgrade. If you like this episode, give me the thumbs up. If you want to subscribe to more, subscribe. And in the meantime, keep on making. Thank you.